Okay, sometimes when you're working with square roots and trying to find the square root of a number, you're going to run into situations where you don't run into nice even numbers. So sometimes there's a way, well actually always there's a way, that we can estimate and see what about is going to be the square root of that number. So I have two examples here, and I want to start over here on the left with the square root of 80. Now to find this, I want to find what are called perfect squares above and below it. Perfect squares are things that have a good square root. 4 is a perfect square because the square root of 4 is 2. So that's something that would be a perfect square. So what I want to do is I want to say, well, what is the perfect square that is just below 80 and the perfect square that is just above 80? Because that's going to help me estimate. So if I'm looking through, I know 7 times 7 is 49. I know 8 times 8 is 64. I know 9 times 9 is 81, and there a second, I passed it. So 81 is this perfect square just above it. So if 9 times 9 is 81, then the one just below it must be the one beneath it. So 8 times 8, which is 64. So these are the two perfect squares right in between. Now, I want to find the root of 80, so I'm going to need to find the roots of these and kind of see what I'm going to be working with. Well, we said square root of 64 was 8, square root of 81 is 9, so I know that the square root of 80 has to be 8 and something. 8 point something, or 8 is a fraction. Well, there's a way that we can look at our perfect squares and figure out what's that's going to be. Well, what I need to do is I need to say, well, what is the difference? How many numbers do I have between 64 and 81? So I can do some quick subtraction right over here and figure that out. And there are 17 numbers in between. Well, that's great because that helps me build a fraction. So I have something 17ths. Well, what I want to ask myself is, of those 17 numbers, what is 80? Well, I have 64, 65, 6, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80. So there's the numbers. So let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 out of the 17. So 16 17ths. That means I'm going to be put pretty close to 9, which actually makes sense with how close my 80 is to 81. So this right here would be a good estimate of what the square root of 80 might be. Now let's take a look, and let's take a look over at the other side. Let's look at 72. And while I'm doing 72, I want you to kind of think through this in your head at the same time. So again, I want the perfect square just above it and just below it. So we're running through perfect squares in our heads, trying to go over it. As soon as you pass it, that's going to let you know the one above and below. Again, we should have wound up with 81, a 9 times 9, and 64. Well, that's great because I already know there's 17 numbers in between, so I already got that down. I know here that this is going to have a square root of 8 and this is going to have a square root of 9. So again, 72 should be somewhere in between 8 or 9. Okay, so now again I'm trying to find, well, 72 is which number? I know I'm going to have 8. There's going to be 17 on the bottom because that's the difference between my two perfect squares. So now I'm saying, well, 72 is which one? Well, let's count it up again. 64, 65, 66, 67, 68, 69, 70, 71, 72. And this time I have 8 out of 17. So we said 80 was 8 and 16 17ths because 80 is real close to that 81. 72 is more in the middle. And if you notice, 8 is pretty close to the halfway point of 17. So this makes sense for our estimation. So estimating square roots, we're looking at what's the perfect square above it, what's the perfect square below it. That gets us where we're going to be in between, and then we can use the difference between those to create a fraction to help us get a close estimate of what that's actually going to be.